Everyone again. This is going to be part 2 of my those low voltage light bulb tests. This one got cut off, so let's just do it. Seriously. It's like my multimeter auto turns on in the night. Yeah, I cleaned up the room way more, but I started doing a little more universal motor experiments. But anyways, let's just get to this. Now, I don't have that socket in the previous video, but I have this and this. This one's going to be easier to use. I'm just wearing heavy things because it's fall, and here in Florida, due to global climate change, it goes down to like 48. Yeah, I also made new cords. This one is for high power loads, and I added capacitor to provide more current. This is a 15 microfarad 200 volts capacitor, so it can withstand the high voltage spikes from motors. And I also use beefy clips, but these are kind of old. I'm planning on buying new ones because, though I've not had these for long, they're corroding really fast. I don't know, after I sanitize them from purchase, they just corroded really fast. I use alcohol, not that drink, rubbing alcohol. The type of alcohol I'm talking about is called isopropyl alcohol. But anyways, let's not waste any more time. Well, I'm using the phone that I play the music on, so I don't have... But anyways, it's going to be a very short video. If all works. Raise the voltage. Oops. Set it down to where it won't go, because we want to see it start going. This is the one that I have pretty much a duplication of. I have it. I'll actually get that one for you, so you know why I'm saying that. Ugh. It's also 65 watts. Just looks different. Kind of like those GE ones, right? Look. Just looks different. And this is an old GE one I found at the Restore. This is from the Restore that I also got the Ace 40 watt accent spotlight and the heat lamp. I got these from Largo, actually, because not too long ago we've been in Largo, and I went to the Restore, and these are very weird. They look normal, but they're 50 watts, 12 volts, with a lovely brass base. And they also use probably that pure tungsten filament, which is better, so it will last long. Oh, another Largo bulb. I'll show you all these bulbs now. So, was that thing glowing? Well, if it doesn't glow, we know we lose connection, but let's get back to the topic. Oops. Yep, there's a loose connection. There we go. So let's send it. That's very dim. Oh, the frosting makes it dimmer. So let's send it down to 4.77 volts. Show you from the underneath side. Taking a very close look. This time I do have that tripod. Wait, are you seeing me? Or are you just seeing blank? Oops, you're kind of seeing just blank. Oh yeah, you're way off actually. I'm so sorry. So, these are the Largo bulbs, I told you. I'll also show you another Largo bulb. But those low voltage ones short this power supply because it cannot deliver that current. It's only like 24 watts. It's only like 50 watts. Plus those bulbs have very low resistance. The bulb is still not glowing, nor heating up at 9.33 volts. And just say it's about glowing now at 12 volts short. Go Max! Sorry. Oh wow, that's beautiful. Oh, you silly battery! Get off of the power supply cord. Haha. See? That's really nice. Again, the camera does the thing that I strongly dislike. Oh, this is getting hot too. Crank down the voltage. Now this one. No, that's the G one. Let's do the no brand one. Now this one, we have to, like, we can not look from here because there's a base thing. Oh. Well, it's drawing current. Well, it's dropping the voltage and humming. Let's actually see what's going on. Oh, I've never thought of that. Why not just see what's going on now? Well, these high voltage bulbs have higher resistance. I'll show you. So that they don't short out the mains voltage, which would be really dangerous. Hope my meter still is functioning properly. We'll know if we measure the resistance. Yep. Probe should be no resistance at all. Doesn't matter. $65-watt bulb is Is this thing dead? No. Oh. The resistance is, let's see, 0.03 kilo ohms. Or no. 0.428 kilo ohm. That is quite high. So that's why they don't short their outlets. And I'll glow. Let's increase the voltage. Huh? Seriously, come on, give me a glow! Huh? What's going on now? Can you see me though? Oh, I think it's getting a little warm. Yep, you can see me. I just want you to be understanding, so I'm not wasting my time here. Yeah, I can't see its minimum voltage, but I said we're going to see what's going on. Set it to 200 volt mode because this is 25 and it's lowest. It's thing below 200 volts is 20 volts, 2 volts, and 200 millivolts. Let's clip the two together. Why did I put the black on the positive? Because this is the hot water. Oh, come on. You must cooperate. Oh, there's some sort of noticeable voltage drop across this system. Unless the meter is not measuring correct voltage. We'll know by if I open this somehow and put the multimeter probes directly. Yeah, this multimeter has some heads. Oh, notice with the bulb. Now remove the bulb. Only goes up one. So maybe this is measuring the voltage drop across this light bulb. So now let's replace it. This one is the same thing. We'll just see at this voltage. Still humming, but not as much. Oh well, this one's much beautiful. This is much beautiful. Look, that is much beautiful. Oops. This bulb is much beautiful. Whoa! That was fine, trust me. Yeah, I also got worried. Luckily, capacitor did not blow. Nothing went wrong. Yeah. See? Again, the camera makes it look ugly. But when it's a dark room, this looks much beautiful and not heating up. So this bulb is way more efficient than these cheap bulbs, apparently. Even if I got this for like $1 or $2, it's a way more efficient bulb, apparently. Even though it's still incandescent, it's probably more efficient that it's like, I don't know. It's just like not the same. So now I told you, I will show you that 1000 bulb, this one. This is 1500 watts. Let's see how many ohms that is. Disconnect the wires. This bulb, I don't have a socket for it. I just found this bulb bare. I like bare bulb. So set it to resistance mode. Okay, now measure its resistance. This is 240 volts. So it should have double the resistance. But what makes logical sense is not true. It's the same resistance as this vacuum cleaner motor. This is 2.6 ohm. That one is 2.6 ohm. So this is that's why it drops the voltage. Now let's set it to 200 volt mode. Using the probes of the meter as my terminal connections. Like this. I'm going to clamp it in a very weird way. So I can use the probes of the multimeter as my terminals. And then connect the other probe. Oh! Look, that is so cool. Right, the voltage always goes all the way down to 8 volts, actually. Oh, I can feel that heat, all that heat on my face. On my face. Whoa! And I shall stop it before it deritrificates. Oh! My dad's going somewhere. But this bulb is really hot. I would not touch it to not deritrificate it. Put it back in the light bulb connection. When we sanitize this box, that box just got completely destroyed. Now let's go to 1/10 of this wattage. I actually got these as a gift. These were about to go right into the trash from my neighbors, but because they didn't need it, so I just said, no, never a light bulb goes in the trash, especially if it's working like this one. This one works perfectly fine. 130 volt, 150 watts. So let's connect it. Of course, voltage drop is way less. And it also glows brighter. Wow. Beautiful. See, I told you it's working just fine. Of course, nothing's perfect. Here's a halogen bulb. Another one. Oops. Don't worry. If this breaks, that's fine. But if the capsule there breaks, then it's useless. I know the video is... I said the video will be short, but I found out there's more. Wow. Well, part 2 is about the same as part 1. 16 minutes. Oh, beautiful. Now let's do the... And I lost the multimeter probe from the terminal. So now you're seeing a lower voltage. That's because, of course, until I've lowered the voltage also. There's a 0.3 volt voltage drop across the bulb, and this, I think. I'll go down all the way. Okay, so just wait till I see the filament start going. Well, I can see something weird's going on. Like the filament is like bending, and it started glowing at 9.13 volts. Oh, what's that fusing stuff in there? But yeah, it started glowing. 12 volts. And max! Oh, that's kind of cool. So, let's now test some motors. That would be fun. Yet very dangerous because, well, let's see what it does. This motor at 120 volts is 1,440 watts. But of course, the reason that one drops the voltage less is because it is a 240 volt, not a 120 volt. Turn off the meter. I can't even leave the motor to sit on its vacuum. I have to let it like this so it cools itself down. Look, Stop! Do not try this at home. Do not try this at home. Why did I just say that? Oh, it smoked. Ugh. So that's how fast it spins at 25.2 volts DC. Now let's go to blender motor. I actually made this blender motor spin way too freely. It was quite stiff, and now it spins very freely. Like, it still has some, but how do I clean that up? Just spray a little WD-40 in it, and then just spin it like this, and there you go. It's gone. Let's see. It's 1,800, 1,600, or 1,800 watts. Whoa. So the body is live electric, or did this just... Well, luckily this is a safe, this is a lab zone, and I'm holding it up so it won't ignite the ground. Plus, I'm not using a switch. I'm using gear clip. And touching the frame of it, not clipping the wire. Ugh! This motor is, after I greased it and it became freer, it's also acting weird. But still works fine. I don't know why. This motor no longer works properly, but it still works fine because it heats up, and when it heats up, the resistance increases, so it slows down. And this makes a huge output voltage spike. I'll show you. Oops. Huh? What's that arcing noise? This is a small vacuum cleaner motor, not blender motor. I don't know how many watts this is. I could buy measuring it from another vacuum cleaner of the same size because they use very similar motor. But notice, if I connect it like this versus like this, this spins like twice as fast because I'm using because it's becoming more less. So there's a reduction in the BEMF. Plus the voltage drops in. That's cool. But of course that does not work with blender motor. With blender motor it's different. It shorts the power supply out because it's configured differently probably from this motor. Let's measure the resistance then. Well, I know this one. And I told you the huge one. Oh, it just ran away on its feet. Hey, don't you run away and hide from me. This one I know I told you is 2.6 ohm. Come back here, multimeter. Huh? Silly. Multimeter, come out wherever you are. I caught it. Now you're not running away. Set it to 20. Oops, I went on the wrong mode selection. Let's start with 200 ohms mode. And then, what's this? 10 ohms. 10.9 ohms. So pretty much 11 ohms. Now let's just check this one. 12.3 ohms. Now the halogen bulb, just this. Of course it doesn't matter. Let's get a more accurate reading by removing it. We already know the big fat, the big long halogen bulb is, oh, that's interesting, 17 ohms. Somehow the halogen has to do with that, or the filament is quite short. But this is why car headlamp bulbs short my power supply out. Or low voltage ones. All low voltage bulbs have this problem. No resistance. Don't think I'm just shorting. I'm doing 60 watt mode, 0.1 ohm. Now 115 watts mode of a car headlamp bulb is only 0.4 ohms. So that's a problem. Now let's clean up the place. Oh, well, I think the part 2 video is longer than the part 1. If this was a whole video, it would be like more than 40 minutes. Oh, I'm just getting silly. Put this bulb back in it. This bulb's box was ruined, so I didn't use it. It was just getting a really ruined box. Like, it was so wrinkled and broken and like that. Though I did like how it was designed. Just it was too broken to store in this. Now let's put this in one, and this one in, and this. Okay. So let's put the motors back. The small universal motors go in my new organization for the DC motor drawer, because I'll pretty much just run them on DC. the AC power supply I showcased in the other video just cannot provide that current. And the big one, it doesn't even detect them actually. And the big motor is too big for that drawer, so it just goes in what used to be the motor drawer, and now it's for large motors. So anyways, I hope you enjoyed. Please rate, share, comment, and subscribe. Thanks for watching. AC motor.